Hello students, my name is Arshan and today we will do the 14th chapter of class 7th mathematics textbook of NCERT, and the name of the chapter is Symmetry part 2. So students, symmetry is an important geometrical concept commonly exhibited in nature and is used almost in every field of activity. Artists, professionals, designers of clothing or jewelry, car manufacturers, architects and many others make use of the idea of symmetry. So in the last part, we talked about line symmetry, different types of polygons, mirror reflection. Let's start this part with rotational symmetry. So students, what do you say when the hands of a clock go round? You say that they rotate. The hands of a clock rotate only in one direction about a fixed point and the center of the clock face. So rotation, like movement of the hands clock, is called a clockwise rotation. Otherwise, it is said to be anti-clockwise. So, what can you say about the rotation of the blades of a ceiling fan? Do they rotate clockwise or anti-clockwise? Or do they rotate both ways? See students, if you spin the wheels of a bicycle, it rotates. It can rotate in either way, both clockwise and anti-clockwise. So, try to find out 3 examples of a clockwise rotation and anti-clockwise rotation and write them down into your notebook. Now students, when an object rotates, its shape and size do not change. The rotation turns an object about a fixed point. This fixed point is the center of rotation. And what is the center of rotation of the hands of a clock? Well, think about it and write the answer into your notebook. Let us move further into our chapter. The angle of turning during rotation is called the angle of rotation. A full turn, means a rotation of 360 degree. So, students think, what is the degree measure of the angle of rotation for a half turn and then a quarter turn? So, students, I can say that a half turn means rotation by 180 degree because the full is 360 degree and a quarter turn is rotation by 90 degrees. So, when it is 12 o'clock, the hands of a clock are together. By 3 o'clock, the minute hand would have made 3 complete turns, but the hour hand would have made only a quarter turn. Now students, what can you say about their positions at 6 o'clock? We can say that the hour hand has made a half turn and the minute hand would have made 6 complete turns. So students, try to visualize things. Now, have you ever made a paper windmill? The paper windmill, just as in this picture, looks symmetrical. But you do not find any line of symmetry. No folding can help you to have coincident halves. However, if you rotate it by 90 degree about the fixed point, the windmill will look exactly the same. We say that the windmill has a rotational symmetry. In a full turn, there are precisely 4 positions. On rotation through the angles 90 degree, 180 degree, 270 degree and 360 degree. So when the windmill looks exactly the same, because of this we say it has a rotational symmetry of order 4. Now here is one more example for rotational symmetry. Consider a square with P as one of its corner as in this figure. And let us perform quarter turns about the center of the square marked. Now, figure 1 is the initial position and rotation by 90 degree about the center leads to figure 2. Now, students, note the position of P now. If you rotate it again through 90 degree, you will get figure 3, and in this way, when you complete the 4th quarter, that square reaches its original position. It now looks the same as it was in figure 1st. So, this can be seen with the help of any position taken by P. Thus, students, a square has a rotational symmetry of order 4 about its center. Now, observe that in this case, the first one is that the center of rotation is the center of the square. Then, the angle of rotation is 90 degree. Then, the direction of rotation is clockwise. And the fourth one, that the order of rotational symmetry is 4. So students, every object has a rotational symmetry of order 1 as it occupies same position after a rotation of 360 degree, that is one complete revolution. Such cases have no interest for us. You have around you many shapes which possess rotational symmetry just like as in this figure. So students, for example, when you slice certain fruits, the cross sections are shapes with rotational symmetry. This might surprise you when you notice them as in this figure. Now, then there are many road signs that exhibit rotational symmetry. So next time when you walk along a busy road, try to identify such road signs and find about the order of rotational symmetry. So think of some more examples of rotational symmetry. Discuss in each case, that is the center of rotation, the angle of rotation, the direction in which the rotation is affected and the order of the rotational symmetry. So students, with this we are at the exercise part. So let us perform exercise 14.2. So students, the first question is, which of the following figures have rotational symmetry of order more than 1? So students, in this we have certain figures and we have to find out the figures which have a rotational symmetry of order of more than 1. So in the first question, we see that the given figure has its rotational symmetry as 4. See, we can see that if you rotate it by 90 degree, we will get 4 points. So we can say that the given figure has a rotational symmetry of 4. Then let us see another image, that is of a triangle. Now this given figure, if you rotate it, we will find that it has a rotational symmetry of 3. We can rotate it by 120 degrees and we will find 3 different positions. Hence we can say that it has rotational symmetry of order 3. Then if we see the third one, this given figure has a rotational symmetry of 1. Similarly students, we have to find the answers of other images as well. Now let us move on to the second question, which is, give the order of rotational symmetry for each figure. Now students, in this question the images or the figures are a bit different. So let us see the first one. In the first one, if we rotate this image or if we rotate this figure by 180 degree, we will get 2 positions. Hence we can say that the given figure has a rotational symmetry of 2. Then let us move on to the second one. Now students, if we rotate this figure by 180 degree, we will get 2 positions. Hence once again we can see that the given figure has a rotational symmetry of 2. So students, similarly try to find out the answers of other questions as well and note it down into your notebook. Now let us move on to our another topic, that is line symmetry and rotational symmetry. So students, you have been observing many shapes and their symmetry so far. By now you would have understood that some shapes have only line symmetry and some have only rotational symmetry, and some have both line symmetry and rotational symmetry. For example, consider the square shape as shown in this figure. Now how many lines of symmetry does it have, and does it have any rotational symmetry? If yes students, what is the order of rotational symmetry? Think about it and write the answer into your notebook. Now students, to move further into this chapter, the circle is the most perfect symmetrical figure because it can be rotated around its center through any angle, and at the same time it has unlimited number of lines of symmetry. So with this students, we are at the part of exercise 14.3. So let us solve these questions as well. So students, our first question of exercise 14.3 is, name any 2 figures that have both line symmetry and rotational symmetry. So students, for this we can say that equilateral triangle and a regular hexagon have both line of symmetry and rotational symmetry. I am sure you may find other answers as well. But now let us move on to the second question, which is, draw wherever possible a rough sketch of, first one, a triangle with both line and rotational symmetries of order more than 1. Second one, a triangle with only line symmetry and no rotational symmetry of order more than 1. Third one, a quadrilateral with a rotational symmetry of order more than 1 but not a line symmetry. And fourth one, a quadrilateral with line symmetry but not a rotational symmetry of order more than 1. So students, let us find the answers of these questions. Now the first one, equilateral triangle. Now we know that equilateral triangle has 3 lines of symmetry and also it has rotational symmetry. So it can be like this if you rotate it by 120 degree. Now the second question, in which we have to make a triangle with only line symmetry and no rotational symmetry of order more than 1. So students, we will draw a isosceles triangle that has only 1 line of symmetry and no rotational symmetry of order more than 1, just like this. Then to draw a quadrilateral for the third question, we will draw a parallelogram which has no line of symmetry but has a rotational symmetry of order 2. Then students, for the fourth one, where we have to draw a quadrilateral, we can draw a kite or a rhombus which has only one line of symmetry and no rotational symmetry of order more than 1, like this. So students, these are the answers. Now let us move on to another question, that is question number 3. If a figure has 2 or more lines of symmetry, should it have rotational symmetry of order more than 1? So students, to answer this question, I can say that yes, if a figure has 2 or more lines of symmetry, then it will definitely have its rotational symmetry of order more than 1. Then students, moving on to the fourth question, which is fill in the blanks. So we have been given shapes, then we have to find out the center of rotation, order of rotation and angle of rotation. So for the first one, the shape is squares. We can say the center of rotation for square is the intersection point of diagonals. Order of rotation is 4 and angle of rotation is 90 degrees. Then for rectangle, the center of rotation is intersection point of diagonals. Order of rotation is 2 and angle of rotation is 180 degrees. Then if we see a shape of rhombus, the center of rotation is intersection point of diagonals. Order of rotation is 2 and angle of rotation is 180 degrees. Then again, if we see the shape of an equilateral triangle, the center of rotation is intersection point of medians. The order of rotation is 3 and the angle of rotation is 120 degrees. Then we will see the shape of the regular hexagon. The center of rotation is the intersection point and order of rotation is 6 and angle of rotation is 60 degrees. Then students, we have another shape, that is a circle. So the center of rotation is center, order of rotation is, as we know, is infinite and angle of rotation is any angle. Then we will take the shape semicircle. So the center of rotation is again center, the order of rotation is 1 and the angle of rotation is 360 degrees. With this students, let us move on to next question, that is question number 5. In this we have to name the quadrilaterals which have both line and rotational symmetry of order more than 1. So students, there are various examples, but to write the answer we can say that square, rectangle and rhombus are the quadrilaterals which have both line and rotational symmetry of order more than 1. A square has 4 lines of symmetry and rotational symmetry of order 4. A rectangle has 2 lines of symmetry and rotational symmetry of order 2. And a rhombus has 2 lines of symmetry and rotational symmetry of order 2. Then students, let us move on to our next question, which is, after rotating by 60 degrees about a center, a figure looks exactly the same as its original position. So at what other angles will this happen for the figure? So students, to answer this question, if it can be observed that a figure looks symmetrical on rotating by 60 degrees, then it will also look symmetrical on rotating by 120 degree, 180 degree, 240 degree, 300 degree and 360 degree, that is further multiples of 60. Moving on to the next question, which is, can we have a rotational symmetry of order more than 1 whose angle of rotation is, first one 45 degree, then second one 17 degree. So students, to answer this question, I can say that it can be observed that if the angle of rotation of a figure is a factor of 360 degree, then it will have a rotational symmetry of order more than 1. It can be checked that 45 degree is a factor of 360 degree, but 17 degree is not. Therefore, the figure having the angle of rotation as 45 degree will have its rotational symmetry of order more than 1. However, the figure having the angle of rotation as 17 degree will not be having its rotational symmetry of order more than 1. We have discussed a lot of things like rotation turns an object about a fixed point, and this fixed point is the center of rotation. The angle by which the object rotates is the angle of rotation, and a half turn means rotation by 180 degree and a quarter turn means rotation by 90 degree. Rotation may be clockwise or anti-clockwise. Then we learned that if after a rotation an object looks exactly the same, we say that it has a rotational symmetry. And in a complete turn of 360 degrees, the number of times an object looks exactly the same is called the order of rotational symmetry. And the order of rotational symmetry of a square, for example, is 4, while for an equilateral triangle it is 3. Also students, we learned that some shapes have only one line of symmetry like the letter E, some have only rotational symmetry like the letter S, and some have both symmetries like the letter H. The study of symmetry is important because of its frequent use in day-to-day life and more because of the beautiful designs it can provide us. So with this students, we have finished our chapter. I am sure you might have understood the concept of line symmetry and rotational symmetry well. So we will meet next time with some other interesting chapter. Till then, bye bye.